Now let's do cosine. Cosine is the one in green. And
which is not the one in red.
yeah, and it just varies just a little bit on a few things. If you were to want to draw y equals cosine x, like if that's something you wanted to do, then you would have to start at 0, 1, and then you draw your graph going down. Okay, and so instead of us being 0 at 0 pi and 2 pi, we end up being 0 at pi over 2, 3 pi over 2, and so on. And basically, by the time we get to 2 pi, we need to be back up here, okay, because this is a periodic function that every 2 pi, the same thing should be happening. So if we start here at the top here, then 2 pi later, we should be back at the top.
Right back where we started.
Right back there, yeah. Okay, so we want to analyze this. So domain, for instance, right here, domain.
That would be all the x values that you could put into the function, and we can put every x value into this function. So the domain goes from negative infinity to infinity.
That didn't change from what it was with sine. Our range doesn't really change either. Even though we're getting to 1 and negative 1 at different spots, that's still the values of y that we're oscillating between.
That we're going between, which is negative 1 and 1. I feel like your 2 dots there are not very good.
Thank you. Thanks. I'm not. If I try to fix it, I'm just going to screw other stuff up. So I'm just going to leave it.
Okay. All right.
This is also a continuous function.
It is.
So that's similar.
We don't ever pick our pencil up when drawing sine and cosine. Those are the only 2 trig functions, though, where you don't pick your pencil up while drawing. All the other ones are going to have continuity
Tangent
issues.
and stuff. Let's not spoil 4.5
Oh,
for them.
sorry.
Increasing, decreasing. Remember, this is the one that required some work. And should we say that we did?
Yeah, we had a slight error, not major,
that we figured out.
And we caught it in between recordings.
Yeah, so we made a note of it earlier in the video, assuming that the editing that was supposed to happen happened, which of course it did. But we're going from negative pi to 0, for example, here. But then the next place that we're increasing happens 2 pi later, and we said it was happening just 1 pi later. But if from this value to this value, from negative pi to pi, there's 2 pi's.
You might draw a bracket in a different color to show.
Draw a bracket around.
Like make a little, and then is,
like from
right there to right there.
How far apart are these? Those are 2 pi
That's
apart.
2 pi apart.
Right. So our increasing intervals, and you find one of them, any one of them.
Doesn't matter which one you pick.
Doesn't matter which one. So I just found, for example, negative pi comma 0. Oh, but I need to put
plus 2k pi.
2k pi. And then 0 plus 2k pi, or you could just put 2k pi there if you wanted to. But it's increasing for any integer that you put in for k.
It increases.
It is increasing in those intervals.
Right. And that's a really, this whole situation with the 2k pi is a really challenging one to try and understand. So if at first you're not getting it, when we ask for increasing and decreasing behavior, write it down because we said so.
Right.
And then as you start doing that, the understanding will take place.
It should, definitely.
But don't stress out if you don't get it all right away.
Right.
Okay, this is going to take some practice.
Right. So now we're decreasing from 0 to pi, as that's just one interval where we're decreasing, but it's going to happen again every 2 pi. So we can say from 0 plus 2k pi, comma, pi plus 2k pi. All right, that's increasing and decreasing symmetry.
This one, if you were to fold the graph in half, right over the y-axis, they're going to mirror each other.
Hamburger style? Hot dog style?
Whichever style it needs to be, it's going to be.
It folds in half, and that's called symmetry on the
y-axis symmetry, because this function is even.
Yes.
Even, boys and girls.
Symmetry about the y-axis. And those two things, the fact that sine is odd and cosine is even, that can really make a difference in calculus. That can really make a difference.
It does get quite important.
Yeah, I can't tell you how many times I've had to deal with that in my life. there's been a lot. Anyway, what's after symmetry?
There are no asymptotes,
No
with this bad boy.
okay.
No asymptotes at all. What about in behavior maybe? In behavior is not happening because just like with the sine function, as you go towards negative infinity, your y values change all the time. And they change between -1 and 1. So we don't approach a specific number or negative infinity or positive infinity.
Right.
And everything I just said is repeated again as x goes to positive infinity. Just you don't have that in behavior.
Right, because we're oscillating back and
Right.
forth.
But it is bounded though. It's
It is
bounded above and
bounded.
below, so it's bounded because there are values that we just don't ever go to for y. We never go past 1 from the parent function.
Right. Maximums and minimums. We've got a maximum here at 0. There's a maximum. We've got another maximum at 2 pi. So there's a clear way to see, okay, those are happening 2 pi apart because one's happening at 0, one's happening at 2 pi.
That's got to be a distance of 2 pi then.
So our maximum is, we have the point 0, 1, but not just 0, 1. We've
But
got
0 plus 2k pi. The maximums are going to be the same thing, except this time, or your minimums. Your minimums are going to be the same. They're going to be -1, just like with sine, except now your minimums are going to occur at pi.
Right down here at pi.
Plus 2k pi. Yeah, there's your minimums.
1, 2, 3, 4, 5, 6, 7, 8, 9. That's everything. So that's cosine. So now let's look at the transformations. That's what's coming next. Like, how do we know what's going on as far as like when we throw other numbers in there?
What's it do?
Y equals sine x and y equals cosine x. Those are great functions,
Right.
but they're not the only things that we could have.
By the way, there's a lot of similarity between these two. So if you can just get where you're really, really understanding one, you should be able to analyze both.
Yeah, because the other one is just a little bit over.
Mm-hmm.
Okay, so